things is 0,
Right.
things going that way, and things going that way, and off must equal time.
Oh, right, okay.
So indoor conservation of energy.
Yeah.
Okay.
Well done.
So, just from physics, if we have 2 meters of thing and 15 kilograms are on top of it, we need to convert that into newtons so we can actually use it. So W equals mg, get the newtons, multiply by 2, and then you just get its torque, which is Newton meters. That's going clockwise, so it's positive if it's pushing down on the thing, it's positive. If it's pushing up, it's negative.
Where's the 2?
The two's going through the radius.
Well, it's diameter because there isn't.
What?
It's just the entire length.
Is it going to be diameter?
It's not the entire length. It's the entire length. It's not circle.
But if it's going, if it goes in a circle,
A diameter is part of a circle.
yeah, that'd still be a radius. Kind of.
Fine, that's the length. If it's like this and we're like that, sure, but then it's different.
But isn't this
like-
still a radius?
It's length.
Is the radius of this?
I don't know. I was never said. It was never said.
I mean, it doesn't mean it's
I loosely read it.
technicality. I don't really care.
Yeah, neither do I. Okay, yeah. The moment of force, yeah, turning moment. Moment of force. You can copy this down. Well, I get the other thing going. Okay, so. Can you all read it there? Not going to bother with the question, I'm just going to write this down. C, A, B. That is 2 meters, that is 3 meters, not the radius, because it's just not. It's 5 meters long. Yeah, pivot point C, 2 meters away from A. A force 10 newtons is applied. So, not having to convert anything yet. Oh, that's it, okay. So, yeah, like I said, 2 meters away, so you don't have to do that, this isn't engineering, so just torque equals 2 times 10 equals 20. I think it has more to it, but 20 anti-clockwise, because it's this way. Anti-clockwise. So around B, so turning moment about A, it means this is the pivot point. But if we have it at B, which means we're using all of this.
C is the pivot point.
Turning moment about B.
So we.
Turning moment about A.
When it shall be
Ugh.
followed.
It's just going to be 10 to 30.
And it's going to be positive, but it. I'm just waiting for this chair to fall a bit and the desk at the same time.
Yeah, pivot point C. Oh, I guess, yeah, so I guess this means if the force is from here, not here, for about B. So about A, about B. So that's just 3 times 10 equals 30 Newton meters. Clockwise, because it's going that way.
You didn't write the 0. I know you said 30, but you didn't write the 0.
That's 3 degrees Newton.
3 degrees north.
Yeah, sorry.
The force is 3 degrees north with no unit of
Newton meters. There.
Lovely roll dice you there.
Yes.
Wow.
Have you copied this one now?
Yeah.
Yeah, but
It's too late now.
Yeah, just copy.
wait, what? We're on B.
There we
There we
go.
go.
10 newtons here. That's A. That's C. Which is 16 newtons.
Why do those 2 meters look like they're not the same at all?
Hmm?
The 2 meters look like they're not the same at all. It was just they're the same length.
It doesn't
I mean,
matter.
it's not
Yes,
to
it's
scale.
not going to be to scale on mine either.
I know, I'm just saying.
Mainly just to believe you all.
It looks fine.
8 and another 2 meters with point B. What is the turning moment around B?
Yeah, so it's using B as the pivot.
Yes. So it's just the sum of parts. So that's 2-way, so 2 times 18, that's 8, nice. 2 times 8 plus, what's the difference? 1, because you can infer. So 16, so just 16, plus 10 times 5. But I did a thing, because this is supposed to be negative. Yeah? So it's negative 16. Anyone have a calculator? No, let's just see if I did this right.
We do have a calculator.
Oh yeah,
Oh, then.
because it's being rotated the other way, it would be going this way. No,
You just do this.
these two are negative for some reason.
Okay.
Yeah, can I get the calculator?
It's just this.
Oh, okay, so it still works out. Cool. Yeah, okay, it doesn't matter. We have to pick one of them. It doesn't matter which way. As long as one side is negative, one side is positive, you
Okay.
still get the right answer. Cool. Yeah, anti-clockwise. Which, that's done by the negative, because clockwise and anti-clockwise, like I've mentioned. Ooh, stuff I haven't done in engineering skills now. Oh, not skills. The course. This is already beyond what I've done in my course. That I've spent too long doing. Uh, newtons. That is 6 meters long. And now it goes 40. B. This is the turning point, of course. Otherwise it would just be 0. So, what is the turning point? Well, that's difficult, so let's just make it flat.
So,
Yeah, let's just make it flat. It's cos. Cos 40, 6 equals
6 cos 40, did you say?
6 cos 40, yeah. Please in degrees.
4.6. Yep, 0.
Yeah, okay. Meters. So we're just going to use that with that. So, again, it doesn't matter, who cares? 2.60 multiplied by 20 equals Yeah, just did that. So 91.9 Newton meters. And because it's going this way, it's positive and clockwise. Everything's understood. We don't need to go over anything. I hope this is recording, by the way.
Funny if it wasn't.
Yeah.
What were you doing the freestyle after that?
If I haven't gone through this, I'll just keep going until it's done.
Oh, really?
Although we're already a bit of the way through.
We've got gravitation to do after this, and we have.
Nope, center of gravity. Well, no, I might just skip that and get one of you to do it because
Sorry.
I can't be bothered.
So who's teaching next?
Well, I'm doing the actual gravitation bit, and one of you are doing the center of gravity.
I was actually teaching Joe. No,
Who's Joe?
Joe, mom.
Okay, I'll just center of gravity then, or whatever it is.
Nice.
Gravitation, we have to explore. What else have we got? And conical pendulum.
We've done that in the pendulum, so we've done the central forces and back circular motion.
After this, we get to that.
Oh yeah, I did pendulum.
The cloth of being.
Yeah, we need to.
Well, I thought each of the topics is one thing and then circles is like 4 topics in one.
Well,
No, this is multiple things as well, though.
Oh, that's nice.
Yeah, that's why I've split it up into 3, I think. Hopefully, this isn't the test. I haven't checked
we
any
actually
past
distribute the parts of the course very well. They put them on our headings, and then but like some of the headings have like 19 different parts, and some have one.
Yeah, I don't. We probably should have looked into this a little better.
Yeah, sure.
It's working, maybe.
Is it?
So now, whoa,
Yeah.
it's like this. Oh my
I
god.
don't believe you.
So scary.
Insanity. That's amusing. Okay, so again, here's our turning point. Actually, probably actually now this is like a pivot thing, and that's A.
Whatever.
So it's going like this on it. I'm just going to draw it like that because I like it better. 50, and then, well, that's difficult to deal with. So, you know, let's make it a triangle. 50, 30, and then, so sine 50, 30, yeah, 30 sine 50, and that's 30 cos 50. Okay, but, you see, this one we cancel because it's acting on a flat beam, it's not going to do anything.
Right.
There's no turning moment on something else. So, we're just going to use sine 60, 50, I can read, and again, so 8.
We're not sure about that one. I just like to say that. We're not sure about that one. I just like to say that.
No.
Do you? Should I?
No, we're not sure about being able to read.
Ah, yeah, fair enough. I was about to say about the maths, I'll fight you.
What's that bit?
Hmm?
To the left of the bracket. What's that drawing? Yeah.
That's an 8. Again, it's
Okay.
just fine thought. Also,
Oh, it's like sine 50.
Yes.
Not
Row
sine
60.
60.
What you get?
I'm going to need 4 meters clockwise.
yay! And also anti-clockwise.
Anti-clockwise.
Wee.
Oh, shoot, I can't do that. Don't worry, I can still
So-
read clocks.
So also, it's negative because it's going that way.
Yes.
But this one doesn't say that, so
Can you
guess I'll
write
go with that.
anti-clockwise? Like, no, I'm asking about the.
Good morning.
Like,
Do we have to write negative or can we just write anti-clockwise?
It doesn't say negative on the slides, which is
That's a bit squinty.
Yeah, just a bit.
Who's to blame? Put the hand up. Who's designing it?
yeah, it doesn't have a negative on it, so.
Can you like decide which way is positive and which way
Well,
is negative?
Yes.
Well, yeah, like we did before, it still gives the right answer
Yeah.
when you do it like that. But for this, it doesn't. It should be negative because it's going anti-clockwise. I guess you can put a negative or say it's anti-clockwise, or if you put a negative and say it's
If you say it, but then if you say it's negative and it's anti-clockwise, does that make it clockwise?
yes,
Oh.
they cancel out, of course. I don't know. It's the stuff I'm doing is what I've been shown in.
I'm just gonna
Engineering.
argue clockwise or anti-clockwise because I feel like adding the negatives is making it weird.
Yeah, that makes
Oh.
no sense.
Oh,
Vector.
Vectors.
It's your boy, but
But that's basically already what we've been doing, except are have you copied this down or should I just?
Yeah.
No.
Point S is a position vector and a force vector is a
oh, it's your fell.
well done.
Wait, look, was it forward? It is there.
So I'm J blah 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 blah. So A minus 3I plus 4J X because X is 6I plus 1J. Well, I'm just gonna do the grid.
6 times.
That's great, so great. Find the moment about S. So, okay, right. So, I'm just gonna copy the grid because I can't be bothered.
T 2I plus 2.
Oh,
And
a
then
point
X.
S and the 4. Oh, okay. Right. I didn't read that properly. Okay, so S T 5 newtons, 6 newtons. That's a lot of newtons, right? That's going this way, that's going this way, and S is nice and over there. What's the position of those two? So 0 running up there, and then
Oh, shoot. Oh, you're on so.
So it's 5 along. Just vector. It's minus 3I, 2I, so 5 difference, and then 4 and 1, so 5 up. Have I gone insane? That's right.
Maybe.
They're both difference 5. No, it's not.
1, 6.
It's 3. One's 3.
Yeah.
Wait, what? Oh, wait, no, I'm looking at the force one. Never mind.
Yeah, okay, so here's that. Simple vectors, which we've already done. Go check out those other videos. And
There you go.
That's 4 meters, isn't it?
what?
Oh, right, 3 between the two. Okay,
Yes. Okay, so we could do it
Was that
like
5?
this.
5I and 3.
No, 34. Wait, no. I just put it in 3 squares.
Yeah, okay. Yeah. So again, we're just gonna act like this is 3 straight down and 5 along. We have no slanted planes apparently. So when it's 3 down, the 5 newtons isn't going to do anything. So just use the 6. So 3, 6 plus, and then again that's a straight line. The 6 does nothing. So it's 5 times 5 equals 5. Add the two together, and that equals a number.
It is approximate.
That's 5 at 18.
Oh yeah,
This one.
I can
Wow. I'm just trying to work out what that is. There you go.
43. Woot. And then
Wow.
again anti-clockwise, so should be negative, but they don't do that here. Maybe the answer scheme actually has it like this and does it properly, but I doubt it. Understood, by the way.
Hmm?
Yeah? No?
Oh yeah, yeah. Well, yeah.
Okay, so this is what I've been saying this whole time. The positive, negative, if it's other, whatever.
That's a weird looking diagram. I'd just like to point that out.
Well, mine one or
Their one.
what? It's just poking a stick.
But what? No, it's a point.
No, I meant like the fingers. Like you can get like an actual stick. It's just that, and then you can like hook something with it.
Yes.
It's just weird looking, right? Anyway.
Yeah, so large. Who cares? Moving on. Yeah, so is this everything I've mentioned? I hope so. We
Speed running.
calculate the thing of this. Whoa. Okay, so we have a 20.2 meter, and then 10, 10. Oh wow, it's centered, I guess. So half of them each. So 0.2 time divided by 2 because you have to, because the moment should be in the middle. I think it's in the first place. So then times by 10 and then I'm just gonna double it. So multiply, just do one of them. The more bending turning moment is here, so it's half of this, and it's this, multiplied by 10, and then I'm doing doubling it, because there's 2 of them, and they're going the same way,
Oh.
so it's going to turn the same way. They're not counterbalancing each other, they're doing the same, but what I should be doing is add the same thing, but I'm lazy, so it's just times 2.
Okay, that makes sense.
Okay.
And I don't really care what the answer is, but it's
Is it not just 2 or something?
that. 10 times 1. Yeah, I just overcomplicated a bunch, so
Yeah, you made it look real weird.
yeah.
You're like, oh really? What are you doing?
So yeah. Also, yeah, you use a clockwise thing. So, but then this is anti-clockwise. Well, yes, it is. So, I think you'd use a negative sign for this, but whatever. Time for a slightly harder one. I'm gonna get you all to do it. See if you've learned.
No.
Simon was only allowed to answer once.
Was this primary school?
Yes.
Which question is we doing?
I feel
Oh,
prejudice
yeah,
here.
Good. With Irish boy.
Not sure if it's prejudice you're feeling.
You're singled out.
Wait, so what's transitionary movement? Like, oh, okay,
Yeah.
like,
Yeah, for if you don't know it's this. All of it is 8. And then
Who said all of it is Kate online?
meters, I guess. Well, it is. So, and then it says 6, but I'm just gonna slap 4 here. Nah, it makes it easier if you do 6 on up here. This is the bending moment part. Yeah, it's O, it's always O. That's up, that's down, that's also down at the end, which is 1.
The diagram looks real bad, but it's not that bad.
It's not. So, what do you do?
You just solve.
Nice one.
Cool, I'll keep that in mind.
Well, actually, I finished drawing the diagram.
Yeah, fair enough. If you're done,
You gotta just
shout
add
out
up the
what you do.
things.
Yeah.
Literally just add up the things, because you all...
This reduce to a couple? No, it doesn't, because the forces don't indicate to 0. Like, there's a lot in the middle.
Okay, go on. Give me stuff.
I don't know if you're right here.
No, you solve it first.
I mean, if we're solving it for the torque, then it's just, well, let's go for 4 times 6 plus minus 3 times 2 plus minus 1 times 8.
Except you should probably do it from left to right.
6.
Yeah, so negative, so 2 minus 3. Again, this is how you're supposed to do it in industry apparently. Down the way, not sideways, but again, nobody cares. So, great mechanics this. As always,
It's
we'll say.
positive 4, not minus 4,
No.
just saying.
Minus 3 times
And then plus that. Again,
4 times 6.
so 6,
Yeah, isn't it?
Take
14,
Yeah, it's 10.
10.
Yeah.
So it's 10 clockwise.
I think.
Yeah, it's 10 clockwise.
Cool. So yeah, this is greater, so I guess clockwise. So it's just positive 10 Newton meters.
That weird ringing noise wasn't in my head, right?
When you say that, it's not got transitionary movement.
Yeah, okay, we need to prove it's got no transitionary movement, which is just the forces, just all the sum of forces. So these are negative, so minus 3 minus 1 equals, no, plus 4 equals 0.
So
And if it's
is
equal
that
to 0,
just
it's
what
transitionary movement. That's how you solve it.
Is a couple just something without transitionary movement? It's got like
Apparently so.
pills on it. Okay. I
Yeah.
mean, if you read the slide that had all the text on it, it would have said what transitionary. is.
True.
I don't know
Let's
what-
take a quick look at it, because I didn't actually read that.
Maybe well, it doesn't actually say it, so.
Lovely.
Samuel just making up.
Turning movement couple has resultant force of 0, overall turn.
Do you have to write anti-clockwise and not just slap a negative on it? Because
I
it
mean,
looks
but
like
you,
it.
you need to tell them which way it was gonna be.
But if it's negative, it's anti-clockwise. It's implied.
It's implied, is it?
Yeah.
I mean, we can check SQA after today, and then we can see if it says in the marking scheme that it has to be minus or anti-clockwise. It could be either, to be honest.
Yeah. Anyway. More vectors.
Oh yeah. I love vectors.
Hello, vectors, my old friend. I hope you copied this down, by the way. Not that there was much work in. Okay, I think this is the second last example, to be honest.
Nice.
Yeah.
Just in time to finish the class.
Okay, so, for I plus 3j with forces yeah, I'm just gonna write it like this because I hate everything. And minus 5. It's in vector format, but that's how it looks like. And then minus 2 plus 5j and I on point, other point. And then, oh,
What?
iron's right, that's right. No, it's 2 forces and then, okay, I'm gonna write the positions first. So 4I plus 3j and then 2I 0j and then we write the forces. Jesus, okay. So 2I, I did write this right. Ugh. So 2 minus 5. Actually, I wrote it right first, and now it doesn't matter. And so, then, so thing, and then 2i, so just positions, no, okay, minus 2 and plus 5. Show that the force is reduced to a couple and stick okay, they just cancel. It's 5 and 2 and minus 5 and minus 2, so they just delete. Understood?
Yeah.
Cool. Reduce to a couple and state movement of the couple. Cool, okay. So then we just solve again. It is a straight line, and I will fight you on that. So 3 here and 2 here. Which needs to be applied in order to be an equilibrium. So, oh shit. It's just gonna be in the middle, I think. Which is weird because is that. Yeah.
Okay, where are we finding the...
Okay, alright. Point A, point B. So we're just gonna find the turning part of both. So A, because it's at 0 meters, minus 2, and these two are 0. 0 meters, so it's not by zeros, nothing. So we just use these. So
Why do we not use those forces?
because we're finding the point of A, and if we use them, well, we do use them, but they're 0 meters.
Oh, yeah. Wait, so the turning point is at A, just because?
Oh, we're gonna find both.
Oh, we'll find the turning moment both A and B.
I'm gonna double check so we don't have to do it.
Okay, no, we just find it around A.
Yeah, just find it around there apparently.
It'd be nice if it told us to find it around A.
Hopefully the actual questions will be more precise, because I'm not a fan of the So,
It'll probably be if you found it on B, it'll be this exact same thing.
Well, yeah. But if it's around the middle,
That was not around the middle.
or what it is.
Oh, wow.
Yeah,
So-
what if they want you to find like the turning moment in there?
Well, then they'd probably say that.
Yeah, but they don't say. What do you want to find it?
so again, this is so we use the 2 because the 4 does nothing. So there 2 it's the minus 5, okay, and then plus 2 minus 5, which equals a number. What does it equal? 4?
16.
Nice. That's something. 16. Wow. Crazy. Need some useful spotlights. So you got all the. You haven't copied it.
No, I haven't read it.
Okay, I'm just gonna check. Okay, hold on. How much further? More than I thought. Great. Okay, so that will probably take both periods then. Does anyone want to break or we're good to keep on going?
I need to go film and see my stabs.
What now?
Yeah.
Right.
Well, you can watch it on nothing.
YouTube.com/. Nine. There's some private mechanics for
Wasn't it
Like
up
chess
there?
mechanics 2020 or something.
Yeah, that's a bit of a link though, because we're further for their YouTube link. You need like 100 subscribers. I think they changed it to that.
Yeah, so you fine with me carrying on?
Yeah, just go ahead.
Nice.
Try not to trip. It's like that one thing in the cube, you know, where you've got like the 3 different bars and you have to step over blindfolded.
Oh shit, I need my mask. Alexander, I reckon I need my mask.
No, over there. That's where we're passing.
Oh, disgusting.
Anybody
Yes,
press the
sir.
table?
Huh?
You change your press the table.
Yes, but I'm looking for Mr. Mackenzie to look over it and shit. Ooh, what's this? If that two forces are parallel but do not form a couple, it is possible to replace it with a single force.
Wow.
Whoa.
It should be noted that if the parallel forces are in the same direction, the resultant force will be between the forces. If they're opposite, it will lie outside the forces.
Yeah.
Ah.
So 3 plus 8, so 11. That's the force. Now to find where it would be.
Wait, where was the?
Round 2.
Yeah, in the middle.
Job done. Next one.
Okay.
Cool.
Are you guys here for the double?
Yes.
Yes.
That's fine. Okay.
Did you steal this table again?
What?
Did you steal this table, or is it going to?
Yeah, I stole that table.
Nice. Let's try it this way. So just. Well, it should be negative, but I lost all care. 8 times 5. Okay, what does that give? I don't know what this would give. This is actually 1 plus. Alright, what does it want?
It just wants 1.
Yeah, because if you're getting it's just a moment of. Again, A is always the point of, I guess.
Right, 11 newtons.
So we just assume it's point A that's always going to be the turning.
It's
So
either
they don't
point
specify.
So in order of needs, it's 0, A, yeah.
That's
So
kind of
it's done. I hope past. Should
How
have
they
put that past
mention
paper.
where you have to find it? 'Cause that's just a bit.
it's like
Assume.
it's like assuming this.
Yeah.
Assuming this, the assumptions made are all assumptions.
So round A, so 8. Whoa.
200 newtons.
Cool. That's anti-clockwise. Wouldn't you know?
Indeed. Anti-clockwise.
Okay, so that's so
So
200 Newton meters is our thing.
Yeah.
So because of the these equal each other, something happens. So yeah, we still need to find how the distance. So a turn of A equals R, which is the distance x.
So the number's going to be 18.2
Yes.
meters.
Yeah. 11. Whoa.
times x.
Also, I like how they use, they say like a turny thing, whereas in physics it's just T equals FR.
Yeah.
Are we allowed to use that? Or would we get marked down if we said T equals FR instead of like A arrow or O arrow?
I don't know because maybe because this one shows direction and stuff. Well, the other one doesn't
Why
really.
is
No, I mean you can still say anti-clockwise at the end. It's
Is it
just
saying R r times x, why is there two x's?
I think it is.
Oh, because it's Rx meters.
Sure.
So like R multiplied by the x meters. It should be per Vx, but you can't do per Vx in PC.
Which is really dumb.
Oh.
Yes, they should have used y, but oh well.
Oh my god.
What is that?
Your parents
It's
can't
ink.
play you.
Oh, I'm gonna get killed.
You go on the run.
Fuck.
At least it's not black. At least it's not red.
Do I have any weight?
Just like you've been stabbed, question mark.
Anyways.
If it was red, that's.
Oh no, I keep the wipes to fill.
Oh no, I got some.
Parallel forces
Is there any
and
glasses wipes on my help this?
No, I got some, that's right.
Okay.
Or you can bring your regular wipes through. Like,
How did I not realise that?
How long has that been there?
Oh, well, ever since I moved that TY, I didn't realise that I've been.
it's just magic.
It's not coming off.
Why is it in the opposite way?
No, it is.
To be like this, not like that. It's annoying.
What the top be.
5 and G. Okay, great.
It's kind of worked.
And 3.
It's not looking like
The little triangle's a bit. turns
Nah,
out,
it's
right?
8K, will never come off.
The little weird triangle is a bit, turns out, right?
I mean, it's like.
A. B.
No, it's from like a laser printer.
Oh, is it? Okay.
So the sum of the forces is
So
3, 6, 14.
it's not like it.
14 G is the
Yeah.
total force. Which is the total force equals this.
The resulting force in any direction must be zero. The sum of moments.
And then let's find round A. Although I think you can do round B as well, to be honest. So again, just distances. That's 0. That's assuming. This is I'm assuming at 2 meters because this entire thing. But the entire thing is 4 meters by the way. So that should be 2 because it's probably halfway. So 5G2 plus 3G4 equals calculator.
5G plus 3G.
Actually, keep it in G. We're gonna need to keep it in G. 10, 12, so 22.
Is it not-
Agreement is
We
my
now
math
need
class.
to know the like radius thingies. Do we just assume
Four.
5G is at 2?
I'm assuming it's up to 2. So then. So it's the RXX a roundabout, so it's 22G over 14G. These cancel out, equaling 22 over 14G.
Wait, 5 divided by G?
1.57, so like 1.663.
Oh wait, R is equal to 6G plus 5G
That's meters.
plus 3G. Which is equal to 15.
That's this point. Okay, so we found the roundabout of A, and then that's this equal slapping that in. Again, this is just all the forces down. It's 14G. Set them equal to each other. This moves underneath. Giving the 22G over 14G. I didn't bother with the G bit because they cancel and give you that. Understood, or should I try and explain further?
I'm gonna have to look at the video because I'm too busy cleaning my stuff. Let me-
So what, 1.57
Yeah. That's what.
meters?
Let's see.
What's the triangle bit? Oh,
Yeah, 1.57.
Yes,
Triangle
that's
is
right.
just
is that like the two?
That's the
a
triangle.
floating mass.
Okay.
No, it's the triangles
No.
where it's been
Just
turned.
look, we're finding the turning at A and the triangle is not at A. The triangle is just
Yeah,
a massive
Okay.
no, we have to find the thing for.
I was gonna think, shouldn't the triangle be on A, because like it says that it's like 6 times 0, because otherwise it would be 0
No, no, no,
one.
no, no. We first have to find this. This could be at A or B.
Or why is the triangle
yeah,
at
to be
like
honest.
1? Why is the triangle at like 1 meter?
Because that's what we're trying to find, where the triangle is. Where the actual turning point is. We have to find another turning point, use the sum of forces, and then we somehow get there.
So, 5 is like 2, which is true. 3 is 4.
So we get that, and then the point of this is finding x of where the triangle is.
And 2 is
Oh,
42.
okay, that's weird. Okay.
It's very strange.
Wait, where did
It's also very bad to find the position if the beam is balanced.
Yeah, it's. Oh, it's great.
Find the turning point.
Wait, 5g times 2, because that's halfway.
Actually, writing the formula of the
Right.
starting point of 8, I'm gonna write that all.
That's how you get 22G.
And then 3g times 4 is 5, and then the 4 is that means half.
Huh?
So 5g times 2 is like just halfway.
Yeah.
And then 4 is the entire thing.
Yeah.
Cool.
Where did the 40 come from?
22g.
Where does 14G come from? Oh, all the forces added together.
Yeah, that's just me adding
Oh,
up
yeah,
all
yeah,
these
yeah.
forces.
It's the new thingy.
Yeah.
So
Yeah.
we just guess, we just say that it's A even though the triangle's at 1.
You can do B as well, I assume.
But
Should I prove
I
it?
don't understand, why would they even put the triangle on the diagram?
Okay, so the triangle is what we're trying to find, okay? So in order to find
The
that, we find the turning.
So
at
this
A.
is where it's supposed to be turning, but we can't find it, so we must find another point. Should I show you with B that it works?
I
But it could
understand,
be
I
from
understand that
X
it
here.
works. I'm just questioning the logic behind why you.
No, it makes.
It's odd. Just
So
remember that
find the
formula.
position of the actual turning point, and the triangle is the actual.
Yeah, but
turning
it
point.
makes it seem like that's the normal turning point when it's already there. But it is that a turning point, and I understand that you can calculate it, but like, it feels weird to put it on the diagram when you don't know where it is yet.
It is a little odd.
Anyway,
Shall we carry on?
Yes.
That's what I was saying, that we should use that point first and then find off the new one. For some reason.
find the reaction at each support.
Hooray. How much time do we have?
Plenty.
Enough. Good.
Is it just me, or do those numbers not add up?
What? 2, 3, and 1 don't equal 6.
Yeah.
They do.
Oh yeah.
Just edit that one, really sorry, huh?
But they do.
So that was Leon. Leon's such a short Leon.
Explain the person that isn't here.
No, he is the
Mine
original,
is-
right?
It's like a bit of Samuel's best bits and like a montage on the channel.
Oh yeah.
Put that in there.
Okay, so.
No, but who's actually going to have the effort to actually be able to?
Yeah, I mean,
Who's going to be bothered to actually do that?
I already put too much effort into this thing.
That's 8g.
8. Oh, G. Jesus, I can't do that. 2G. And then I'm gonna have to do it this way too. This is that's gonna make things a little confusing. And P.
This is P, that's Q.
Wait, hold on. Find the reaction at each support. Okay, so we just go this way and this way. That's all. So we're going to find A first, because A is our boy, equals
Okay.
2 times 8. G.
I'm alright.
Wait.
Did I copy
Oh,
that?
no, wait. 5 times 3g.
18 plus 15. Wow. Last is around 8.
So what did I miss when I was on the floor?
Oh, why hello there. How did your thing go?
Yeah, I finished my first statement now, so.
Nice.
Nice.
I'm
31
also
or 33?
Yeah, this is 31. What the fuck are we doing now?
It's just the same thing, bro.
What's there two of them though?
You calculate one and then the other.
2 times 8 is not 18. 16.
Oh yeah.
You.
I mean, that means
Oscar just went along with it.
that makes up for talking about statement. 3 plus 2 plus 1.
Yeah.
That's it. Right?
Well, I mean, yeah.
I mean,
Okay.
Oscar just following along without question. That's a bit.
3G
3G times 1.
plus 8. Oh no, no. That's 1. And then 4 times 8.
Yes.
Which equals 3 as 69 equals bacon. 32. 32. Find reaction at each support. That's technically P and that's Q. Okay.
Okay.
Yeah, you've got that.
Yeah, so this is, well, mostly wrong. Anyway. Okay, so this should be a Halla times 6 as well on it, because that's the distance from all the way here. So it's actually 31 over 6. This is also over 6 times 6. Again, yeah, so it's 31 over 6 and 35 over 6.
So
Do you know why? Because it's the entire thing and there's 2 holding top.
Yes.
And then we have to find the reaction. And then find this at equilibrium. So, at equilibrium, you know, this force equals that force, and sum of forces equals 0. Oh wow, we have to just supplement. So A equals B. That's probably the way it is. It might be the other way around, but again, I'm out of cares. 30 G plus
Mm-hmm.
yeah. So A plus B equals, and then 8 and 3, like we've done before, not the random stuff I've been doing.
P and Q not AB, but doesn't matter. Same thing.
Yeah, I don't wanna use them just out of not wanting to, but that should still ring true. So 31G over 6.
Yeah, you wrote correctly. The same.
Thanks. Plus 35G over 6. That makes 66. 11 G. And then 11 G.
And now.
0 equals 0 as required.
1 by 0 equals 1.
Oh no.
A from A plus B.
So we add the rotations and compare them to the forces down upon it. So the sum of forces should equal 0, which we solve those in, solve it, which gives you 11. Add those together, those give 11, 0. Then rearrange, which gives you 0. Or 1 equals 1. No, 0.
It equals 0.
Yeah.
11G equals 11G. The is no.
11G is required. That makes more sense, but I'm just slapping that in because felt like it.
Oh, and then
And this is the final one.
Oh,
is it?
Yep.
This is the last question there is.
Yep.
Ah,
And I'm gonna have a lie down.
Your
Yeah.
chair run is falling apart at any moment. Really keep showing your toes.
Yeah. Wait, I can't sit down. That's lovely. Aren't enough chairs.
You just sit on a table.
Oh,
But pretty much
oh,
chair.
right.
Yeah, but that's a chair for big people.
Non-parallel forces in equilibrium.
Wait, so
So-
was that parallel forces in equilibrium?
Hmm?
The previous one.
Yeah, they were. So I'm just gonna draw it because writing out questions is hard deal. We are at 56 minutes.
Yeah, because we're going on for like a period and more.
Yeah.
Yeah, you might need to do some minor editing this time.
No.
Remove Samuel's good
Or you
mistake.
could send it to Andrew and get her to edit it.
Oh,
That isn't edited, it's the rendering time that's the problem. For her, a 10-minute video takes an hour or two.
Oh, that's nice.
Yeah.
Wait, did the spell piece drop finally give up and you've used it all?
It's very small.
Nice.
Don't feel like. I don't have nails. Should I just use it until it's gone?
No, there's still a small drop in the store.
Yeah. Okay. Too high. Nice acute angle. 15 degrees. And for it's halfway, so it's a length of 2r. So r here, r there. That's in the center of 50 g. Then a tension this way of 26
Oh, that's 50.
degrees. So double angles. Ain't that fun?
Ew. Oh no,
Oh,
double
yeah.
angles.
Good shit. So, alright, like we've done before, that is a thing. That is just r cos 15. You know, because we don't do these angles, we just make it flat and job's done.
Is it not 2 articles? 15? Or do we just go from.
Possibly.
Yeah,
I think it is
two.
It is 2r.
Yes.
It is 2r. Okay, and we're just gonna leave it like this because it's too painful. Okay, so this, I'm gonna write stop here. So that's tension. So again, we can do stuff to it. No, it's like that or something.
What?
Nice. Yeah, it's weird. It's up and along like this. And that's, I think, a right angle. So, I think this is T sine 26. That's T cos 26. Not to remember why.
I mean.
I have it in my jotter.
We could do that. Make it a right angle.
Yeah.
Right to 60.
Oh yeah, so I have it the other way around. But it is, yeah, you make it into a right angle.
Just via magic. No, you just put a straight line in the horizontal.
Definitely
Sign.
wouldn't be able to.
I'm making a joke.
But you see, oh yeah, this should be horizontal. This is again component parts. So we don't use this one because it's flat now that we've done it. So this is useless.
Yeah.
So now we only use sine, we set t sine 26.
That thing's for like the bar being horizontal now, right? And it's like horizontal and then
Yeah, so the bar is now horizontal. The is now
yeah.
We even know what T is.
We're trying to find T.
Oh,
find the
right.
tension. Yes, we're finding tension. Okay, so ours should cancel out.
Yeah, that was 40. Okay. T equals 26, R equals 15 can be ignored as 0 along. Oh yeah, no, that.
Yeah, that's what I've been saying. So, oh, I forgot the 50G. Yeah, okay. So we are
Oh, I understand.
100 GR cos 15 equals times two. Oh, okay, so the distance. 2R
That's why.
T cos
Okay. Yeah, I get it.
26.
I understand that thing.
Good. So then we rearrange for tension, which is here, not over there. So
Wait, no, we want R sine, not R cos.
yeah, I messed up. Okay. 26. So here, sine 26. So we want the tension from here. So we rearrange to R. The R's cancel. So I'm just gonna rewrite it again. 100 G R cos 15 divided by 2 R sine 26 equals T. This cancels. So then you're just left with
T
that. Calculator, please.
That P. What is that? What is that?
Oh, why did I do that? Okay, that should be 50 then.
Why is it 2T?
Hmm?
Why 2T?
Because it's the length. It's the length of the force, you still have to get that. Because how much tension you have to, it's still, that's pushing up, so that's still 50
What did you want to put
kilograms.
the calculator down?
50G cos 15 divided by sine 26, I think.
Can you say that again? So,
50G cos 15. It's on board divided by sine 26 times 2.
Okay, so they are just a bit dumb and have still used R cos 15 even after saying don't use R cos 15.
No, for the
So
different.
look, it says T cos 26 and R cos 15 can be ignored. And
Yeah,
then in the calculation,
I
R
just
cos
ignored
15.
this sentence because
Yeah.
it makes sense if you just do it what I said.
Like and subscribe.